Okay, for question 1, part A, for the integers from 40 to 70, for part 1 we need to write down a common multiple of 6 and 8. So the key word here is a common multiple. So we're not looking for the lowest common multiple or anything. So an easy way to start then is if we just multiply 6 and 8 together, we get 48. So that'll be a common multiple between 6 and 8. And it is in fact between 40 and 70. So our answer then is 48. Now we need an odd number where the tens digit is double the units digit. Okay, so this is for part 2. So we want the tens digit to be double the units digit. So if we double a number, well, that means we're multiplying it by 2. So 2 times anything is going to be an even number. So our tens digit then is either going to start with a 4 or a 6. So if we halve 4, we get 2. So this number here, or the tens digit, is double the units digit, but we wanted an odd number. So it can't be 42. And if we halve 6, well, we get 3. So now we've got a number where the tens digit, which is 6, is double the units digit, which is 3, and it is an odd number, 63. So our answer is 63. Okay, for part 3, we need a number that is both a square number and a cube number, and it has to be between 40 and 70. So if we write out some square numbers, so if we have 7 times 7, well, that is 49, and if we have 8 times 8, well, that is 64, and no other square numbers are going to be between 40 to 70. So if we tried 6 times 6, well, that's 36, so that's less than 40. And if we went 9 times 9, well, that's 81, so that's greater than 70. So our only two square numbers are going to be 49 and 64 that are between 40 and 70. And cube numbers, so if we had, say, 3 cubed, 3 times 3 times 3, well, that's 27, so that's 2 less. If we had 4 times 4 times 4, well, that'll be 64. And you can see that's going to be our answer because it's both a square number and a cube number, and it is between 40 and 70. So our answer then for part 3 is going to be 64. For part 4, we need a number that has exactly 3 factors. So if it's between 40 and 70, we know 2 of the factors are going to have to be 1 and then the number itself, so we can't have any more factors. So you're going to actually need to look for a square number, and the answer is going to be 49. And the reason is, well, the 3 factors will be 1, 7, and 49. Because we multiply this factor here by itself, 7 times 7, would get to 49, or 49 divided by 7. 7 divides into 49. If you tried any other number, you can see you're always going to get more than 3 factors, or if it's a prime number, you're just going to get 2 factors. So for example, if I picked the number 57, well, 1 is going to be a factor. 3 divides into 57, but then we need to think, well, 3 times what is 57? And it would be 19. So straight away, we've already got 4 factors, so it can't be 57. Okay, and you could try that with any other number. You're either going to get a prime number, say 41, and then your factors will just be 1 and 41, and any other number, you're going to get more than 3 factors. So exactly 3 factors is 49. Okay, so that is question 1, part A. For question 1, part B, we need to put one pair of brackets into this calculation to make it correct. So at the moment, it's obviously not correct, because if we remember our BIDMAS or BEDMAS, so we have our brackets first, and then our indices or exponents, and then divide, multiply, add, subtract. So if we do our multiplication first here, 7 times 5 is 35, and then we minus 2, so we get 33, and then plus 3, then we get 36, so it does not equal 42. But we can notice we've got 7 times something here. We know 7 times 6 is 42, and if we put our brackets here and here, then 5 minus 2 is 3, and then 3 plus 3 is 6, so we would do our brackets first, and then we do our multiply, so 7 times 6 is 42. Okay, so that would be part B. Now for 1C, part 1, we need to write 234 as a product of its prime factors. So we can do a factor tree here, is one way to do it. There's a couple of different ways you can work this out, but I'm going to do it using a factor tree. So we'll do it over here. So we get 2, 3, 4. Now you can pick any two numbers that multiply together to give 234. That will work. Or you can just start dividing by prime numbers and seeing if that divides into 2, 3, 4. So first of all, we can notice that 2, 3, 4 is an even number. So 2 is a prime number. So 2 divides into 234, and 2 times 117 equals 234. So 2 is a prime number, so we'll circle that. 117 is an odd number, so we can't divide it by 2. So the next prime number is 3, and if we do 117 divided by 3, well, we get 39. So 3 times 39 is equal to 117. And now 3 is a prime number, so we will circle that. And again, 39 is an odd number, so we can't divide it by 2, but we can divide it by 3, which is the next prime number. And 3 times 13 is equal to 39. And now both of these are prime. So if we just go through, I will write them down in order. So we know that 2 times 3 times 3 times 13 is going to equal 234. So therefore, 234 as a product of its prime factors is going to be equal to 2 times 3 times 3 times 13. So these here are all prime numbers, and you can use your calculator to check that that does equal 234. So that's always a good way to check your answer. For question 1C, part 2, we need to find the lowest common multiple, or LCM, of 36 and 234. So to do this, we're going to start by writing both of these numbers, 36 and 234, as a product of their prime factors. So we've already got 234 as a product of its prime factors. We did that in question C, part 1. So we'll find 36 then as a product of its prime factors. So we'll do another factor tree. So we'll start with 36, and now we just need to find any two numbers that multiply together to give 36. You can pick any two, it doesn't matter at all. So we know that it's an even number, so we know that 2 will divide into 36, and 2 times 18 is 36. So 2 is prime, and 18 is also an even number, so we have 2, and 2 times 9 is 18, so 2 is prime, so we'll circle that. And 9, well, it's odd, so 2 doesn't divide into 9, so we'll choose the next prime number, which will be 3, and 3 times 3 is equal to 9, and 3 is a prime number. So we have then that 36 is equal to 2 times 2 times 3 times 3. Okay, so what I'm going to do now, there's a couple of ways you can do this. I'm just going to draw a couple of Venn diagrams here, just to make it clear what we're doing. So I'm going to draw one circle like that, and another like that. So where they overlap, which is this part here, I'm going to write the factors that they have in common. So if we look at the product of prime factors, well, they've both got a 2, and they've both only got 1, 2. So I'll put a 2 in the middle there. And we've got 3 in common, so this 3 is in common. So I'll write a 3 in there. And we've got another 3 that's in common, so we've got a 3 there. And then we just need to fill out the rest. So if we call this circle on the left 36 and the one on the right 234, well, 36, what are we missing? We're just missing a 2, because we've already got the 2, the 3, and the 3. So we'll put a 2 there. And then for the 234, well, we've got our 2, we've got our 3, and we've got a 3. They're all in the overlap of the two circles. So we're missing this 13, so I'll put 13 here. And now what we have to do is just multiply all these numbers together. So we'll multiply the 2, this 2, the 3, the 3, and the 13. And then we're going to get 2 times 2 times 3 times 3 times 13. And that is going to be equal to, we can get our calculator up here. So we're going to have then 2 times 2 times 3 times 3 times 13, and that is equal to 468. Okay, so 468 then is the lowest common multiple of 36 and 234. Okay, and that is the end of question 1.